Are they really going to leave with an empty bus?
I don't know, they look pretty mean.
Okay, first of all, yeah, I'm sorry I missed most of today. The problem with having a conference in your hometown is that the, teaching still has to be done, the dog still has to be walked and whatnot. So also today I'm going to give a kind of I don't know, after dinner talk, but pre-dinner. So you've been here all day, and so I've just got a couple of philosophical observations about a couple of different programs in quantum gravity as regards time. So if we think about quantum gravity, a general approach, the set of research programs, you're trying to marry together quantum field theory, our best theory of the really small, and general relativity, our best theory of the really big. And they're different in many ways, but one way in which they're different is their treatment of time. And so when you look at the two theories, you could sort of, and you look at the various programs out there, although you can expect that quantum gravity will change both, the way you thought about general relativity and the way you think about quantum field theory. It might be that you sort of, you use one, sort of trust one more as a sort of stepping off point, and then you may make various commitments about time in certain ways. So to the extent that general relativity really doesn't do nice things to time, if you sort of jump off from general relativity, then you may end up having a theory of quantum gravity where time becomes even more deflated than it already is in general relativity. Or if you start off with quantum mechanics, quantum field theory, where time at least is still non-dynamical, and you treat that, start that as your jumping off point, then that may lead you to a theory of quantum gravity with certain features about time. What I want to do is just look at two different ways that could work out, and then make a couple of points about both of them. Okay, and so that's the talk, a tale of two times. Now you're thinking to yourself, dear God, Callender, don't go with the corniest setup of all time for a quantum gravity talk. Don't do it. Don't do it. Yes. That's the best of times. So we begin with causal set theory, which is often claimed to not only give you a kind of robust time, but it's really robust. So some people claim that in causal set theory, not only do you get back a kind of a real good time, but also you could even rescue the sort of more commonsensical, intuitive notions like a flow of time or objective becoming and things like that. And so I believe David talked about that earlier today. And so here's a quote from Sorkin. One often hears that the principle of general covariance forces us to abandon becoming. To this claim, the causal sequential growth dynamics provides a counterexample. It refutes the claim because it offers us an active process of growth in which things really happen. But at the same time, it honors general covariance. In doing so, it shows how the now might be restored to physics without paying the price of return to the absolute simultaneity of pre-relativistic days. And so I'm going to sketch through some of this for a little while. This is all comes from a paper that Chris and I recently wrote. That paper, that model of co-authorship was unique to me because it was sort of, it's more like a fight than a kind of. so he thought that causal set theory, really, was going to provide a sort of new, novel sense of time. I thought because I'm a little bit older, not that much older, but a little bit older, more, more sort of cynical about the world and everything. Thought it's not gonna, it's going to be the same old story as with relativity. And that's the version of the talk we're getting today. So with David's talk, he probably went through the basics of causal set theory. So is there any reason why I should go through that? No. Chris says no. So it's fair enough. I can just skip these slides then. So we want Cosset, Yeah, we're gonna make the shuttle. So if you go back to just a regular relativistic space-time and special relativity or in general relativity, there's this kind of dilemma that that you can see when you try to. Suppose you want to pick out. Suppose we focus on the idea that there's a special present, a real special now. Then, and that now would be the thing that becomes or flows or that. Then in regular relativity, you have this kind of dilemma that any identification of a present in special relativity. Well, so first we could put it in special relativity, then we can put it in general relativity. Either answers to the presentist. So the presentist is somebody who believes that the now is special, ontologically special, physically special. It's not just epistemically special, but really, really special, because it's the only thing that exists for them. Anything that either answers to the presentist explanatory request or is compatible with the structure of Minkowski spacetime, but not both. Okay, so you could take something like take in natural Minkowskian coordinates, you could take the t equals constant surface. It'll have a lot of nice features that correspond with the now, with what your pre-theoretic conception of the now. But of course, it's not. It's famously, because the relativity of simultaneity is famously not relativistic. You could grab some other things that are relativistic. So just grab, sort of the event of, say, a particular McDonald's opening. Let's call it Mc event. So Mc event, it's generally covariant. It's completely fine as a thing, but it doesn't. But if we were to identify Mc event with the now, it would be pretty lame, and the presentist would not be happy. So you have this kind of tension where whatever you try to figure out would be something that would be relativistically, something that would correspond to the now. Then it's probably, it's really hard to make sense of when you then go to relativity. And the same is true when you go to general relativity. And so, I've a chapter, a kind of tedious section of a chapter of a book I'm writing, where we're going through like a bajillion different possible conceptions of a present and showing that they fail in one way rather than the other. Either they wouldn't answer the presentist explanatory demands, or they are not relativistic, even when we move to general relativity. So this leads to this sort of suspicion that really it's the same old song and dance when you move. So now, this sets up the sort of dilemma, and then we're going to see whether in causal set theory whether it's the same old song and dance. So what would the present be in causal set theory? So we could make various proposals for what the present might be, and then see the challenges. So, kind of first natural try, if you think about it, if you think again as a kind of t equals constant surface in Minkowski spacetime, then you think of something like this. So you think of something like a maximal antichain. So it's a maximal set of events such that any two events are incomparable. So here's one. So this set of all of these events. But of course, just like in in relativity, there are different simultaneity is relative. There are different ways you can slice things up. Same to here, and so there are other ones which are also perfectly good. And so then you'll have all the just like in regular relativity, you would ask, well, which one of these sets is the right now? They're all these perfectly good ones, and no one of them is special. Same thing here. None one of these maximal antichains is special, and so why pick any particular one? It seems like you're back to the same old, song and dance. Okay, second try requires a little bit of background for motivation for where it comes up. Now, in special relativity, Howard Stein, in trying to rescue what he calls becoming in Minkowski spacetime, proves this little theorem, in which he puts various conditions on what he wants becoming to be, and particular, so he's looking at a relation R between two events. So this is in Minkowski spacetime, but it's not in causal set theory. Looking at R between two events, says you want R to be reflexive, non-trivial, non-universal relation on Minkowski spacetime. And then he wants it to be invariant under the automorphisms that preserve the time orientation and is generally Lorentz covariant. And then Stein shows that this relation R between 2 points A and B holds for some ordered pair of points A and B, et cetera, so if such that AB is a path-pointing time-like or null vector. Sorry, if it's a path-pointing, for some A and B, let it be such that it's a path-pointing time-like vector. Then for any pair of points, Rxy holds if and only if xy is a path-pointing vector. In other words, for some event, all the events that are in the path light cone of it have become for it. So if we think of that as objective becoming, then Stein says, I've saved objective becoming in relativity, because I can always just grab any point and then look at all the points that have become for it, and that set of all the points in the past light cone for an event is relativistically invariant. So Chris and I were interested in, well, it seemed to us that on its face that something like Stein's theorem should hold in causal set theory, but then it doesn't, which was kind of interesting. And then the counterexample to it then suggested a sort of another try apart from maximal antichains. Okay, so that's where we're going with this. So here's a non-Hegelian subset. So on this call set, a reflexive and transitive relation R can be defined as follows. So we've got AA, BB, CC, DD, and then notice the things that are sort of space-like are included here. So it's not the set of all things that are time-like. In the past light cone, because we've got these counterexample here. And intuitively, what's going on is that anything where the points share the same relational profile will be a counterexample. As you're intuitively, when I'm thinking about Stein's theorem, I'm thinking about doing all the different symmetries and operations, and since the space-time is continuous, you then won't get this kind of thing, because there'll always be all those other points so that there won't be the same relational profile. Here, in this kind of sparse case, although we could embed it in something much larger if we wanted to, you have the same relational profile. And so you have this kind of possibility of these non-Hegelian subsets.
Why isn't it Hegelian?
Why isn't it Hegelian? I don't know. The early version of the paper described it as a Hegelian subset. Then I think David Meyer, didn't Chris send you an email asking whether it was Hegelian or non-Hegelian?
I interpreted Solomon's paper for him. So.
Yeah. There remains maybe an open question about whether it's Hegelian or open or non-Hegelian. Maybe the two, the thesis and antithesis give rise to some kind of new synthesis. Anyway, if you look at this, you think, well, okay, that's interesting, but now look, is there a way we can just focus on these guys, and maybe these guys could be present? And so that's the idea of the second try, is to quotient out, quotient out all of those other, so we would just go into R here and get rid of everybody but, B and C, C and B. And this would give us, which is kind of surprising, it would give us, especially if you think about it from the point of view of causal set theory, where the whole thing is just defined in terms of causal precedence, that from a theory with the heart of relativity in it, that you could then define a kind of automorphically invariant way to define co-present, which is kind of cool. But the point we want to make here is that you still get the same kind of trouble. In fact, there might even be a way in which you could make it even more rigorous, and rather than just a kind of informal dilemma, you might even make it more rigorous, because we would need many large Hegelian subsets consisting of nearly maximal antichains if we want this to correspond to the presentist's explanatory needs, if we want it to really sort of look and feel like a present. But then if you do that, but then if you have those, then you might be introducing a kind of regular lattice, which would then become, a violation of Lorentz invariance. And so you'd have this kind of tension embodied right here between if you get them big enough and doing their job well enough for the presentist, then they end up, having a problem with relativity. If they don't have a problem with relativity, then the presentist isn't going to care about it. So you get that kind of dilemma again. Okay, so right now, David is sitting there thinking, I don't give a shit. Because I know, this. I didn't think of this part of thing. This is as sort of saving becoming anyway. It was really in the dynamics, and so, in any way, people who like presentism and becoming and all of that stuff, they didn't really want something like Stein's theorem saving them anyway, because that's a theorem that's sort of timelessly true on a manifold. And so it's not really the kind of observer-independent becoming that they wanted. They want the universe coming into being, and this is just sort of a label of describing. If you're at this event, those events have become for you. If you're at this event, those events have become for you. That just seems kind of like adding some English words to various bits of the space-time manifold, and not really robust. So let's look for something more robust. So let's take let's look at the dynamics of causal set theory, not just the kinematics. If we look at the dynamics, then this is where really the hope is, the heart of the idea that there's some kind of real passage embodied in the theory. So you see many people talk, saying things like this. So here's Rideout and David and Sorkin. The phenomenological passage of time is taken to be a manifestation of this continuing growth of the causet. Thus, we do not think of the process as happening in time, but rather as constituted time. Now, that feels deep. So now this is now where we're talking about something more robust. Let's think just briefly about the law of sequential growth. And so you have those kinematic axioms that I blew by, and then now there's the law of sequential growth. Now, what the exact law is an open question, but in the beautiful theorem by David in 2000, it shows with certain minimal conditions, you can sort of narrow down the class of all possible laws of sequential growth. For us, it's not really going to matter what it is, but just this idea that you're going to have start off with an element, and then there's going to be a certain probability it's going to be born in a space-like way with respect to that element. A certain probability it's going to be born in a time-like way, or null-like. And you're then looking so the dynamics is specifying transition probabilities for moving from one causal set to another with one more element in it. So you can imagine an order of element births using integers, 0, 1, 2, etc., such that they are consistent with the causal order. So if x precedes y, causally precedes y, then you give it label x as before y. As each new coset C prime is born, it chooses a previously existing coset C to be its ancestor with a certain probability. And Rideout and Sorkin constrain the dynamics to be a part of this class called generalized percolation. Right, first three quick remarks. Well, let's see how quick they are. First remark is, so you have this picture then of, sorry, let's just go back. So you have this picture then of this you're starting off the universe with this sort of Big Bang, the empty set, and then an element is born, and then another one with a certain probability, and you've got transition probabilities of giving you the probability of this thing growing, and in that you can definitely sort of see the idea that there's this kind of becoming in the universe with this all of these different events, it's having a certain probability of coming of being born. So in this idea of the continual birth of the universe, you then, the birthing of different new events, as given by this transitive percolation, and then the universe, percolates into existence, and so that you can see this idea of becoming arising quite naturally. First thing I did want to point out, though, is that just to keep in the back of your mind, a kind of tenseless, non-growthy, non-becoming picture is fully compatible with this. If you think about, any kind of stochastic process, you think about it as defining a sample space, sigma algebra, and a probability measure. So you can sort of run this percolation out to infinity, and then on this kind of picture, what you get is really just this triple of a set of all the histories, a probability measure over that, and the sigma algebra. And that's perfect. That's perfectly tenseless with no becoming or flow or distinguished present or anything like that. Okay. So it's possible, but what we're looking for to see whether something better from the point of view of becoming is. Notice the second remark here is that there's something odd here, right? You've got the time in the percolation dynamics, and yet the things that are being born are spatiotemporal events. So that's kind of weird, because then it seems like you've got two times. Because you've got this time that's this parameter of given by the percolation dynamics, and you've got the time inside the actual object that's being created. It seems like there are these two times. So people in causal set theory, of course, are aware of this and have something to say about this, and we'll get to that in a moment. But let me just first of all point out, there is a connection to an age-old philosophical problem in philosophy of time, which is this debate between C.D. Broad and Jack Smart. So Smart says, you think time flows? Well, how fast does it flow? And then you get into, somebody saying, well, it's like 1 second per second. And other people say, well, if it's 1 second per second, let me cross out seconds, and then it's 1. But then people say, well, no, you shouldn't cross out the seconds, and there's this really kind of scholastic debate about whether you should or shouldn't cross out the seconds. And so there's a big question about whether it really makes sense to speak about time changing. If you think of change as the variation of things in time, how can time itself change? Broad says, well, the sense in which time changes is not that sense. It's a different sense. And then you say, well, what sense? And he says, it's a sweet, generous sense. And now, for me, I get off the boat right there. But lots of distinguished people, like Broad and others, say, okay, I can make sense of that and I can live with it. So I don't want to get off the boat here so I'm personally getting off the boat here. But the rest of, but many quite distinguished and reasonable people don't jump off the boat at this point. And so anyway, I just want to mention that there is this similarity between this problem and that problem. I don't know why that's there. Third remark. What exact sense of becoming is desired here in causal set theory? And so here's a quote from Sorkin. It says, "Art now is approximately local, and if we ask whether a distant event space-like to us has or has not happened yet, this question lacks intuitive sense. But the opponents of becoming seem not to content themselves with the experience of a situated observer. They want to imagine themselves as a super-observer, who would take in all of existence at a glance. The supposition of such an observer would lead to a distinguished slicing of the cause set, contradicting the principle that such a slicing lacks objective meaning, covariance. So it seems like what he wants to do, so if you're the philosopher, metaphysician, you are that super observer, right? Because you are thinking, you're wondering what reality as a whole is like, and if you were wanting this worldwide tide of becoming, it seems like what Sorkin is offering is more like drips and drabs of becoming and not sort of a worldwide tide. So he's wanting something from the point of view of, from a particular observer's point of view, not the point of view of the super observer. And so the traditional advocate of the tense theory of time, becoming, presentism, and all of that, is advocating a view from that point of view of that super observer. And so if you don't want that, then you could have got something like what he wants here, just an ordinary relativity anyway. So in particular, something like the kind of Clifton, Hogarth, world line dependent becoming, which is a kind of generalization of the Stein. That would give you the same kind of thing, where I could talk about, at a certain point, what points have become for me. And I'm not really then talking about that kind of picture of the whole universe, coming into being in some way. But Chris and I wanted to press on then, because we wanted to look to see, is there a conception of becoming which is one, maybe not the one that Raphael would like or hope for, but hope for even better, the sort of from the super observer's point of view. So can we think of this? So suppose we bracket the 2 times issue, and suppose we just think of this percolation dynamics as giving this kind of worldwide tide of becoming, of actualization. Well, can we do that? Well, we can, but then it runs into a bit of trouble, and again, it's this kind of dilemma popping up, because now we need, because you want the theory to satisfy general covariance. In causal set theory, people talk about discrete general covariance. And so, and the way it works out is that you're thinking that if there are different paths to the same cause set, then the probability along those paths should be the same. So the probability of traveling, getting to there should be the same whichever path I take. Now, so you have this kind of picture, that the world might have become this way, or the world might have become this way. But now the covariance is telling you, well, I can't really say it came one way rather than the other way. So, in particular, let, the A be Alice's birthday party and B be Bob's birthday party. Intuitively, it seemed that there should be a fact of the matter about whether, the world happened such that Alice's birthday party happened and then later Bob's birthday party happened, versus whether Bob's birthday party happened and then Alice's birthday party happened. But that difference is going to have to get erased here to make sense of this. Oops. I think we decided these pictures didn't work. Is that right? So you have, sorry, I should have said, so you could imagine a kind of picture where you, so John Ehrman has this kind of picture where you imagine so that there is a fact about what actually happened, but then that really does violate the general covariance and violates really the spirit of the causal set theory program. And so if you don't want to do that, then you are led down a strange path that in our paper then takes this strange path. I won't go all the way into it, but we were thinking, if we were really determined to find some sort of objective becoming in the theory, we were thinking, well, there is some gauge invariant feature of the world in this causal set world, and it's you know, that the, well, first of all, we know that dynamics can be given a gauge invariant formulation. And one thing we know that is gauge invariant is the number of elements. So there is this, right? But it's just that you're going to have to pay a huge price to implement that plus the general covariance. And so you can't say, you know, if we think of this is either the Alice and Alice first or Bob first, and we say it doesn't make sense to see which one happened first, then you can't say what that stage is like. You can say it has two, but you can't say which two. So if you are willing to pry away the individuation of events from the details of the events, then you could do this. So you can think about, so here, C2, it doesn't have Alice's birthday and Bob's, so that's C3. I should have labeled differently, it would be, sorry about that labeling. Let's focus on the number of things, 3, 2, 1.